Hey, good morning. Welcome to today's CHDH seminar. I'd like to start by acknowledging the Wurundjeri people of the Kulin Nation, the traditional owners of the land on which we're meeting, and pay my respects to the elders and traditional knowledge holders. It's a great pleasure to introduce Professor Jakob Hohwy, our speaker for today. He is the director of the Monash Centre for Consciousness and Contemplative Studies, and his own lab is called the Cognition and Philosophy Lab at Monash. He is a philosopher. His PhD was in philosophy. I think he spent about 6 years subsequently working in Denmark, and then came to Monash, where he's been for 17 years or so. He has been and continues to be one of the key people in the area of predictive processing, and we're going to hear about that today. And he has relatively broad interests. His work reaches out and makes connections with areas like neuroscience and psychology, and psychiatry and computational models of perception and cognition. So really looking forward to what you have for us today.
All right. Thanks, Charles. It's great. Thanks for coming out. Right. So when I was invited to do this, let me just see. This was the title that Andy kind of put in my head. So the question from Andy was, predictive processing, is it totally dumb or potentially interesting? I thought about that as a title for the talk, and I thought, well, things live forever on the internet, so I picked the less interesting one. But I'm happy to kind of play ball, Andy, and go with that. The answer to that question is yes. And what I'll do today, so my strategy is when I talk to philosophers, I dazzle them with my amazing empirical studies and science and data and so on. And when I talk to real scientists like yourselves, I befuddle you as a philosopher. So it'll be a fairly high level talk, and hopefully it'll serve. So don't expect any mathematical models. Right? Don't ask. Oh, you can if you want, but we'll see about the answers. And hopefully it'll serve to kind of just situate where I think predictive processing is nowadays, and how it might speak to some of the things that you're doing in your work, of which I have a kind of vague idea from knowing at least some of you, but obviously I don't know everyone who's here. So speaking as a philosopher today, fairly high level. One part is just, what do we mean when we say predictive processing? And then a little bit of looking at what it might be good for, and kind of addressing some of those things that Andy raised as well before. So what is predictive processing? It's this kind of loose framework that a lot of people got excited about when Carl Friston in particular started writing about predictive coding and free energy principle and so on. But of course, it has a long intellectual history going back. Lots of different scientists and philosophers have been working with this, going all the way back to Alhazen, Helmholtz, and Kant, and so on. It's quite an interesting history. And in the 20th century as well, there's lots of really interesting work. But, Friston is the main kind of proponent, I think, in the last 20 years or so. So we wrote various books, Andy Clark and I, and Neil Seth's new book is worth reading as well, for focus on consciousness. It's really taken off. And Neil has had lunch with Oprah. That's how far we're going. I recommend the Active Inference book from MIT Press, free to download, by Thomas Parr and Giovanni Pizzulo and Carl. Really just sets out kind of active inference and the predictive processing framework as it looks in a lot of people's heads nowadays, I guess. My take has kind of evolved from this focus on predictive coding in the predictive mind to the idea of self-evidencing. So that comes up in this paper from 2016, I think, on the self-evidencing brain. And you heard it here first. It's the first time I announced it, that my next book will come out next year with MIT Press, called The Self-Evidencing Agent. So moving from the predictive mind to the self-evidencing agent, and trying to kind of extract some of the philosophical aspects of that idea. What we had early on, we were very infatuated with these kinds of ideas of predictive coding, prediction errors going up, predictions going down, resolving with some bells and whistles around precision weighting and precision optimization as you go up. And we would say things like predictive coding is all the brain ever does, and it explains everything. I'm not sure that's an actual quote, but this is pretty much the sentiment from 2010 and the first few years of excitement there, which is, I kind of still maybe believe that a little bit, but it's also a bit naive. Of course, the brain does a lot of things. And in a sense, the self-evidencing framework is trying to just broaden the scope a bit and say there's lots of things that the brain is doing in order to minimize its uncertainty or expected uncertainty or expected prediction error or free energy. So that simple idea of prediction errors going up and down, predictive coding in the brain in some kind of hierarchical ordering gave rise to a lot of research. We did a bit of that, for instance, with hierarchical frequency tagging in EEG studies. Marta has done a lot of work in this vein as well. From very early on, we met first in 2005, I think, when you started working on these things. So if you look in the literature, in the neuroscience literature, there's a lot of work inspired by the idea of predictive coding. But nowadays, really, the talk is much more about active inference than about predictive coding. So a lot of it starts with active inference, which is a framework for decision-making and planning, where essentially agents infer policies that they expect will minimize the free energy. This is set out in this book we talked about before, which is surprisingly readable because Carl wasn't allowed to write any of it. So Thomas and Giovanni did most of the writing in it. So policy is a mapping from actions to observations, or a probabilistic belief about a state transition, which is under my control. If I look over here, then I will observe these things, for instance. And the expected free energy, we can think of it as the expected prediction error or the expected uncertainty. So it's as if you ask, given what states my model makes me expect that I will occupy, how surprising will this policy's outcomes be? And you go for the least surprising outcomes under policy. You go for the policy that will give you the least surprising outcomes, given what your model of the world is, given what your model of your expected states are. So predictive processing, when we talk about it now, is really a split between perceptual inference, or the minimization of variation of free energy, or active inference, which is minimization of expected free energy. So you have perception, and you have action. I think that there's an increased focus on trying to understand perception also through the lens of active inference. And that's really where a lot of our current work is lying. So a lot of the focus is down on the active inference side. A good meme for understanding what is going on between perceptual and active inference is the action perception loop. You will have seen drawings like this many times. So on the left here, we've got the agent with the internal states of the brain, let's say, for humans. And on the outside here, we've got the true hidden states that we have to infer on the basis of sensory input. And we endow also the agent with some active states, so the agent can now act in the world and go around in this action perception loop. You do something and you observe something new, hopefully what you expected, and you update your model in various ways, and you go around and around. This is a useful meme to think about what happens. And all that, predictive processing says is that the internal states are self-organizing in such a way that you will encounter as little uncertainty as possible. And that's the way to infer what the true hidden states are and to keep surviving, essentially. So I got quite interested in a motif, a kind of concept from philosophy of science called self-evidencing. Comes from Carl Hempel, other people interested in abduction and inference to the best explanation are quite interested in it. So it's self-evidencing. You look out the window one morning, there's some footprints in the garden bed outside your window. You go, there's some evidence there. I wonder what explains that. And you come up with an explanation. There's been a burglar about. And so the explanation will explain the evidence. And at the same time, in this kind of weird, benign circle, the evidence becomes evidence for the explanation. So if someone says, why do you believe that there's been a burglar about? Well, I've got evidence for that. It's the footprint. Right? Why is the footprint there? Well, there's been a burglar about. That's my best explanation of that. So you get this nice self-evidencing circle. And that concept has been taken up by the predictive processing, free energy principle kind of way of talking. Essentially, the idea is that for a little action perception loop where we've got the agent on one side and the worldly causes here on the other side, we can think of what the internal states are doing as explaining whatever evidence comes across, and that evidence then becomes evidence for the internal model in this case. So self-evidencing is the idea that we act both mentally and physically, so mentally in terms of attention allocation and so on, in many different ways to maximize the evidence we have for our own model of the world, and thereby also for our existence. So self-evidencing both captures this circularity, but also this idea that when we apply this to agents, we acquire evidence for our own model. And as long as we acquire evidence for our own model of who we are and what the world is about, we acquire evidence for our own existence. So we act, these are different ways of putting out, we act to maximize encounters with explainable prediction error or to minimize uncertainty in the long-term average with respect to our model. If you look into the literature, for instance, as set out in the MIT book that I showed before, you see that there are various decompositions of the free energy principle, which is just the principle that is captured by the idea of self-evidencing, where we can find in these various decompositions that Carl and Thomas and others have been developing a lot of the aspects of human cognition and decision making that we're after. So with minimization of variation of free energy, we get perceptual divergence, so how wrong are you, and surprise. We get complexity and accuracy in, and for expected free energy, we get, just by reorganizing the terms and now thinking about not the actual uncertainty, but the expected uncertainty, we get notions of risk and ambiguity in, or utility and epistemic value. And all of them are scored in the same currency of free energy, of uncertainty, expected uncertainty, or actual uncertainty. So this is what really drives a lot of the work around active inference in terms of decision-making, for instance. And it's quite elegant, I think, that you can squash everything in under this one objective function or two objective functions in this case. Mechanistically, the way it's meant to work is through precision control. So the idea is that you're able to pick the policies that have the best balance of risk and ambiguity, or decide whether to act for utility or act for epistemic value, so explore, exploit. All of this is done mechanistically through precision control. So just with a cartoon, it's the idea that what the cognitive system is doing is controlling the precision gain, the gain on input and on certain kinds of actions in order to navigate itself towards its expected observations, either through updating its own parameters or through selecting observations under a policy. So precision control is just this idea of essentially attentional allocation in a very broad sense. Okay, so is this totally dumb? Well, there's a kind of early, this is totally dumb reaction, which is if you have an organism and all it wants is to reduce its own uncertainty, it should just seek out a dark room and sit there and do nothing, because then you won't have any surprises, right? And the whole, so it would indeed be very dumb if that was the case. Like, and probably smart people wouldn't be working on the free energy principle if it was that dumb. And it isn't that dumb, because prediction error minimization or uncertainty reduction is relative to your model. And so if I actually end up sitting in a darkened room, that would be because my model makes me expect to sit there. And for creatures like us, we don't sit in dark rooms because we expect to get fed, clean the house, pay the utility bills, and all those kinds of things that actually takes us out of the darkened room so that we can keep occupying our expected states. So everything is relative to the model. So that's why we leave the dark room. Maybe some creatures, this is a marsupial mole, they have no eyes, they kind of live it's out in the sun there, but mostly they're in a dark room because that's what their model makes them do. Right? So the dark room problem is, I've never understood why people got into a tiff about that. So other kind of fairly dumb thing, I've tried to make a drawing, a cartoon of it here. So it's the idea that if you have, in this case, 5 different little agents, they might start out from some high precision priors around the homeostatic states. For instance, I expect to have heart rate in this kind of area, in this kind of domain, or whatever temperature range I expect to occupy. There are some homeostatic priors that have very high precision that no evidence will dislodge those. But in order to occupy those homeostatic states, there's lots of degrees of freedom in what I do. So not all creature will end up in the same position because we have to go exploring. We encounter certain things that then makes us stop exploring and start exploiting, whereas another creature might be serendipitously lucky and get some really good information that allows them to go on and discover where the best patches are and so on. So you can get lots of diverging paths, which is kind of dumb because then you can't really say that anything is wrong. Right? Everything that an agent does will be right because it will just be a reflection of their priors. So this is kind of comes back to the complete class theorem, where for every behavior you observe, whether it's this guy, this guy, this guy, you'll be able to say, well, it ends up here, even though this one might look quite maladaptive because that's the priors that they have. And so they're just minimizing their prediction error relative to those priors, and that makes it rational. So that's kind of dumb. And the trick, I think, is to kind of look at how we can use that to inform us about how we talk about irrationality and maladaptiveness and so on instead. Totally dumb. Interestingly, so what I've set out so far is what we call the high road, the self-evidencing road to the free energy principle. There's also a low road, and it's not worse to go by the low road. As you know, from Scotland, you can walk either along the lake or up high. The low road is just observing that prediction and minimization just plays a role in all these different cognitive functions, and we can kind of string together a story that suggests that by and large, uncertainty reduction and so on is quite important for cognitive function. And that's fine. Andy Clark kind of likes this route. I like the high road. I don't know why, but I do like it because it has this very fundamental idea of existence, what it is for anything to be a thing. That comes out in a lot of Tristan's writings. It's quite intriguing, and if you're a little bit kind of inclined towards ontology and metaphysics, it's kind of cool that now I know what a thing is. And essentially what we have here is a Markov blanket, where we have some internal states and we have some blanket states. And this idea of a Markov blanket, I'm sure some of you will be very familiar with this, has been used to kind of capture cell membranes, and the human neural system, maybe the human body, but also for I think there's a paper recently about ant colonies with Markov blankets around them and so on. So it's a very generic idea of what it is for something to be a thing. So the free energy principle is a theory of everything, which I find quite fascinating. Because philosophers have a hard time with things in general. How many things are there in this room? That's a famous philosophy question that's hard to answer. Okay, so what is predictive processing good for? I've talked a bit at a very high level about how philosophers like myself see what predictive processing is, very much in the kind of self-evidencing, free energy, active inference direction. What is it good for? And here I'll give you some philosophical things that hopefully just connects via a thin thread to maybe some background knowledge you have from when you did a little bit of philosophy back in the day, or to some of the work that you're doing now. My starting point for this is that if we look at what the agent is doing here, when an agent minimizes their free energy or engages in self-evidencing, it seems tractable to me because they can do that. The objective function here is driven by two things that the agent does know, namely their internal states and their observations. So this suggests that when we look at a system that is, if it is really self-evidencing, its behavior conforms to the free energy principle, we can view it, we can conceive it as self-supervised in a very fundamental way. It can do it without getting any help from the outside. It doesn't need labeled training data or anything like that. And I'm aware that self-supervision and unsupervised and so on have technical meanings for a lot of you, and it kind of varies a bit from area to area. It's interesting that there is a debate in philosophy that goes back to Wittgenstein and the rule, something called the rule-following considerations, that is essentially about what does it take in a very fundamental sense for something to be self-supervised. And I think that the self-evidencing kind of framework really spells that out. So when I look at a system that conforms to the free energy principle, I'm kind of sure that I'm looking at something that can do what we need it to do, namely be self-supervised. So I'm mainly interested in what we can do in that sense. It's fine with having unsupervised systems. We can do lots of interesting things, but it doesn't give us a fundamental understanding. The other kind of philosophically interesting thing here is that if indeed everything works via precision control, it's just mental action essentially that allows the agent to entrain their body and go around, move their eyes around or move their body around in order to sample the expected observations. If that is indeed all that's happening, then we get a kind of quite disembodied picture of a solitary agent. You're just sitting there behind your sensory organs. You're not really acting in any real way. You're just controlling precisions of the kind of message passing that happens in the brain. And that's a picture that is kind of a little bit old-fashioned, which is why I like it. And it's contrasts with a lot of embodied cognition, inactive cognition type frameworks that have become quite popular. So I'm kind of pushing back against some of the kind of embodied cognition, but we'll see a little bit later that things can become a little bit more interesting. So self-supervision, disembodiment, and with that comes also skepticism, good old-fashioned Cartesian skepticism. So remember that from the inside here, what the system is trying to figure out is what are these true hidden states? Because the better I know about the true hidden states and the kind of interactions that happen between hidden states, the better I'll be able to predict what's going to happen down the line. So the better my model is, the better I'll be able to predict things. That means, though, that setup means that technically there could be an evil demon sitting out there just controlling, in old-fashioned Cartesian skepticism, there's an evil demon just controlling everything that gets pumped in via my sensory organs, or an evil scientist and we're brain in a vat matrix type scenarios. That just follows straightforwardly from drawing the Markov blanket in this way and saying that everything is a matter of inference, causal inference of the sensory causes, of the causes of my sensory input. That's kind of cool because skepticism is not a problem that can kind of go away just by pretending that it doesn't exist, which actually a lot of philosophers now are going down that route, especially in the embodied cognition type approaches. For them, the possibility of skepticism is like a diagnosis of a bad cognitive framework. But I think, well, it's a good framework, and skepticism follows. And actually, Descartes was kind of right, but only kind of right because if the system, if the agent, the brain in a vat in this case, actually manages to exist for a certain period of time over some time span. So we have an existing thing, namely the agent. And it does so by controlling positions internally and thereby acting in certain ways in the world through the active states in order to get its expected states. Then the daemon actually has to copy that. The daemon is on the clock in order to keep the organism alive. And so we can kind of open the door and get true knowledge into something just by the very fact that we exist. So I hope this is not too obscure. But basically, if I think that I'm looking at a room and there's a window out here, I can look out there, get evidence in to confirm my hypothesis that there was a window over there. If everything is really controlled by an evil demon, then they'll have to give me something. They'll have to kind of conform to that. So something in the evil demon's head will have to know about my states as well. So this very general idea of coupled oscillation between what's inside of the agent, in this case, inside of the Markov blanket, and what's out there in the external world. I feel as if I didn't explain this as, it's just a very simple idea of conformity, but it's kind of nice. The picture of the evil demon in this case is taken from sleep paralysis depictions. Don't know if anyone has experienced sleep paralysis. You wake up in the middle of the night, you're paralyzed, and it feels like there's a demon sitting on your chest, weighing you down, and it's a demon with a kind of weirdly distorted face. I like this image because it suggests that skepticism, evil demon skepticism, is only a problem if you can't act, if you're paralyzed. The moment you can act, you start entraining your evil demon to do your bidding. Right? And that breaks the kind of 100% skepticism. I told you it was going to be philosophy. So once we write that in, that kind of coupled oscillation with the environment, we get something more than just the disembodied solitary agent that we saw before. So that picture is true. It's true that you are just sitting there behind your sensory organs, just controlling positions in order to frantically get your expected observations. But we also know that this has to be embodied and inactive. We get that from the skepticism story and the demon story, that you have this coupled oscillation, and we can't get one without the other. So this to me is a nice combination of old-fashioned internalism and Cartesian skepticism and kind of newfangled, embodied, inactive cognition, where we get the best of both worlds. But when you talk to kind of hardcore embodied cognitive scientists, they don't like this. Like they don't like a compromised position. So that's quite an interesting dialectical situation to be in. Okay, so that's getting the embodied cognition back in place. It's getting knowledge in the external world back in where it belongs. The next thing I want to highlight in terms of what is predictive processing good for is something that we didn't talk a lot about back in the first kind of wave of enthusiasm for predictive coding and so on, namely diversity. And I showed you this picture before. There are many routes that you can go through when you self-evidence, simply because you might have some high precision homeostatic priors, but you're let loose in a variable environment. And of course, we can go all sorts of different routes there. For creatures like us, who have a certain kind of body, a certain kind of set of expectations for homeostatic states, and so on. Other kinds of creatures like marsupial moles and others will have other kinds of homeostatic states. So they will start in a different place and of course end up in different ways. But even within one species, say, we can have lots and lots of diversity. So the policies that we select to make our selective samplings of observations in the world are driven by our beliefs. As I said, probably highly precise homeostatic beliefs. Most other beliefs are learned and depend on fairly idiosyncratic balancing and serendipitous balancing of exploit, explore, risk, ambiguity, accuracy, and complexity considerations. And that to me is nice, because it means that we can embrace diversity in a very different way. And then some interesting questions arise about, well, what is false inference then? If everything you do, as I said before, is kind of right relative to your model, then what does it mean to even be wrong? And also something about how, which will be in the new book as well, about how do societal norms emerge? Like, how do we say, no, this is Trump, he's a psychopath. What he's doing might be rational by his slides, but actually it's wrong, so on. So there's a nice kind of reorientation of the way we ask some questions once we realize that diversity comes into the mix quite easily. Okay, now it's kind of going all right. The last part of the talk will just be kind of just highlighting some ways in which you can study this, or this active inference has been studied. We'll go through that fairly quickly. I said that the free energy principle is a theory of everything through this idea of Markov blankets. If you have a Markov blanket that exists for some period of time, you have a thing. It might be very transient. It might be something that doesn't look like a traditional thing, like a battery. Markov blankets it's a very kind of broad way of conceiving of a blanket. You can have quite a few different manifestations. There's some nice work now being done by Friston and Lancelot da Costa and others around path integrals, where we can begin to see and address some questions around different kinds of things that are out there. So here's a rock, here's maybe some single-cell organisms, and here's a mammal. So here we have an inactive, passive thing. So there is no active states. So the rock can't act on its environment. We can still describe it in terms of a Markov blanket. Then we get to active things. So now we have some internal states, we have some active states, and the active states can act via the sensory states on the external states. And then we have what in this paper is called strange things, which includes mammals. And the difference between active things and strange things here is that there's no arrow from the active states back into the internal states. So here we have, from the active states, we have an arrow going into the internal states. We don't have that here. So in order to get up, as it were, to mammals from simple things, we remove something, which I find quite interesting. An active thing here could be something like a thermostat, where its actions in the world directly tells it what its internal states are, right? Whereas for mammals, it's not like that. The mammal has to infer what its actions were, right? So you're taking something away and making it, in a sense, worse. It functions worse. It should function worse than a thermostat, but it gives it the opportunity to learn about itself and form hypotheses about itself and essentially generate a model of itself. So here you get a kind of detachment from the world, right? From its own actions in the world. And you get a kind of imperative to model its own agency, to infer its own agency. And now we're getting close to something that is kind of interesting to consciousness science and cognitive science at large, which is not so interesting, which is why no one does the psychology of thermostats, I guess. Okay, so I've listed some things that I think are kind of promising and positive and intriguing about the self-evidencing framework, which is where predictive processing sits nowadays. Something around what true self-supervision is, something about epistemology, skepticism, the existence of the external world, a new way of capturing the idea of embodied cognition, lots of room and scope for diversity rather than just funneling everyone into the dark room. Some interesting questions about psychopathology and false inference. What does that look like under a Bayesian scheme? And I think we're beginning to kind of ask new questions about a very standard description that we see between normative accounts and descriptive accounts. Here's a description of what the brain is doing. here's a description of what it should be doing. And with the free energy principle, we get something that has a kind of weird duality between descriptive and normative, I think, and maybe even opening the door to ethics and political philosophy and other kinds of thicker concepts that could be interesting to look at. And papers are beginning to emerge in these types of areas that are inspired by predictive processing. Then there are lots of questions, of course. I'm not sticking my head in the sand on this. You know, you always get people worried about falsifiability. I'm not so worried about falsifiability for principles, like the principle of least action in physics is a principle, is not falsifiable. You just write, you know, descriptions of systems that conform with the principle, and the free energy principle is pretty much the same. What is falsifiable is the way that the free energy principle is then translated into process theories for particular systems like humans and human brains and so on. So there's a nice story around falsifiability. And scientists are kind of adorably infatuated with Popeye and falsifiability in any case. Philosophers have kind of left that behind a little bit. I'm sure you're all very sophisticated non-Popperians. Is it distinctive? That's a really good question, I think. Is this whole thing actually distinctive in the sense that, is it different from what you can do with other frameworks? There's a bunch of papers now coming out from Noor Sajid, who's just amazing, who's really putting pressure on what can you do with reinforcement learning in order to make it look like and do exactly the same things as active inference does. And so for her, whether you go with the active inference or the reinforcement learning frameworks is a matter of, do you like a first principles account, or are you happy with kind of retrofitting solutions into reinforcement learning to make it do the same thing? So for her, it's not really distinctive. The two frameworks are equivalent, at least for active inference and reinforcement learning. So that's interesting. There's also an element of, if you read some of Fristen's work, it's, you know, looking at different kinds of domains and in all sorts of different scientific disciplines and saying, well, that can be made to conform with the free energy principle. So reinforcement learning, but all sorts of different types of areas. That doesn't mean that the free energy principle is better than those traditional disciplines, right? Different disciplines can maintain the way they are, do whatever they do. And so somehow the free energy principle becomes this kind of unifying framework that leaves everything in place. But then it's not really distinctive in that sense. And there's some interesting philosophy of science questions there. The last thing I want to talk about, and I think I can do that in around about 5 minutes, so it'll be just a kind of quick stop along some examples of research that has been done. Is it of scientific value? You know, even if there are questions about falsifiability, even if we don't really know if it's distinctive, does it generate some interesting questions? It does, I think, from the philosophical side of things, but what about the science? A lot of the work that I've been looking at is in consciousness science, which is super nebulous and fraught with conflict and all sorts of problems. A lot of people don't really know what we are studying when we study consciousness at all. And what Anil Seth and I have been doing is trying to propose a different theoretical approach through something like predictive processing, where we take predictive processing as a systematic basis for identifying the neural cause of consciousness, rather than proposing yet another kind of, you know, self-standing theory of consciousness from the top down. We just say, well, we know that the brain works, or we assume the brain works according to the free energy principle. We assume that it implements active inference in various ways. Well, what does that tell us about consciousness, given that we know that consciousness is something that arises in the brain as well? And so it becomes a kind of journey of discovery instead. So self-evidencing is not a theory of consciousness in itself. It's a theory for consciousness science, which might paint a picture in the end of the types of predictive processes that are involved specifically in consciousness rather than not in consciousness. So it's like a journey of discovery instead of looking for something like integrated information or global workspace theory or whatever it might be. So what we're working with here is this idea that active inference is necessary for a change in conscious perception, so that you basically don't get any conscious content in your consciousness unless you engage some kind of mental or bodily action that allows you to sample observations under a policy. In other words, the slogan is to see is to look. So to consciously see is to actively look, where to look is to control your positions on your self-evidencing. And we're doing this, you might have heard of these adversarial collaborations that Templeton has funded for consciousness science. And we've got one where we are comparing something called neurorepresentationalism, which is a bit like old-fashioned predictive coding, active inference, and integrated information theory. So that's a very interesting consortium with a bunch of people involved on our side and replication labs and so on, and where we've had to come up with predictions against IIT and against predictive coding and in favor of active inference and so on. So the core idea of this is just a nice kind of confronting image of retinally stabilized images. So you might be aware of this, where you can do it now with better equipment, but back in the 60s and 70s, they put a little suction cup with a projector on the eyeball, so that when you move your eyeball, the projected image kind of follows your movement, so you can't selectively sample in the image anymore. And what happens is that the image then begins to fade. And there are various physiological explanations for that, but the active inference explanation is, well, there's nothing of interest here anymore. I can't check my my predictions about what I would see if I were to look at it in a different way, and therefore it becomes unconscious. And this kind of thing is then unfolded in, here's a very early study from Friston with face recognition, where you've got 3 hypotheses for what the face might be. You allow the eye to sample under these different hypotheses, and you end up with a winner in terms of the evidence that is accumulated as you sample the sensorium using active inference. So here it's the idea that conscious perception is the process of actively sampling observations on an inferred policy, and then you narrow it down, because lots of things that can do active inference are not conscious. So you got to narrow it down to some ways of that aligns with conscious creatures. So in strange things like we saw before with the mammal rather than the thermostat, maybe using something called sophisticated active inference, where you form inferences about the beliefs that you will have in the future, not just about the observations that you will encounter, and maybe with deep parametric and causal hierarchies. Some of these are set out in this paper. Thomas Parr did some nice models here, just in terms of generating some actual work of truxel fading. So truxel fading is where it's widely used in consciousness science. Fix it in the middle, the color blobs should disappear quite quickly, even for a lot of you now. So he models this with active inference, with a PUMDP, and then uses the same model, but now without eye movement as part of the idea, but instead you have attentional movement or mental action for binocular rivalry. The same model works quite nicely, and there's a couple of predictions that come up as a result of that, empirical predictions as well. Christopher White, who's a PhD student now with Max Shine in Sydney, is also working with us in the centre, has this nice sequence of papers where he starts out by looking at the kind of conceptual predictive processing explanation of global workspace theory, and then he models that with Ryan Smith as well, to get an active inference account of DeHaan's workspace theory that resolves a couple of questions around the involvement of the prefrontal cortex, which is one of the standing debates. So what he does is he writes the PUMDP. In this case, it has 2 levels. Just going through this, I know, very quickly. Runs this through the process theory and generates synthetic ERPs that he then, in this case, qualitatively compares to the actual ERPs seen in studies of inattentional blindness and other kinds of cases. So if you're interested, it's a nice kind of trajectory of theory development and then modeling. And the next step, of course, is to not just qualitatively compared, but to actually fit the model. Lars Sandler-Smith is a PhD student in the center who works a lot with Antoine Lutz. And he's done a really nice, again, in this excellent journal that I'm editor for, of meta-awareness. So 3 levels of POMDPs that are able to act on each other in order to ask questions like, what am I perceiving? What am I trying to do? What am I paying attention to? What am I trying to pay attention to? And then going up to meta-awareness. How aware am I of where my attention is? Am I trying to maintain awareness of my attentional states? So trying to capture meditation states in particular. So he's a meditation fan, Lars. We'll skip over this one. Several of my students are working on active inference as well, psychopathology, defabrication experiences in meditation, or cessation experiences in meditation. And Beth here is working on optimism and optimism bias, where you gave psilocybin to some rats, we observe that they behave in a way that looks more optimistic, and we model that, and then we do the data fitting. So we fit the data properly to model and find that the parameters that shift in the active inference model are indeed the kinds of parameters that you would expect if the rats become more optimistic as a result of taking or being given psilocybin. The last thing I'll mention is this paper led by Andrew Corcoran, who's a postdoc with us. And he's working on this Templeton consortium on adversarial collaboration. And we started talking with Carl about what should post-Popperians do when we come up against something like adversarial collaboration. And so we're using free energy minimization in a meta-scientific way to set out a way of comparing different hypotheses, even if they're as diverse as IIT and active inference, in a way that can kind of put them all in the same horse race and accumulate evidence because they're scored in the same currency of free energy. So if you're interested in how some of these ideas can be applied to scientific methodology, I think it's a nice model, even if I do say so myself. So predictive processing, totally dumb versus potentially interesting. Yes, it's kind of totally dumb in specific, quite interesting ways because it's tautological, it's conceptual, it's analytical, which is kind of dumb because it doesn't teach us anything we didn't already know. It's analytical. It's philosophically, methodologically, and scientifically valuable in various ways. Speaking as a philosopher, at least. So that's all.
We have time for a question.
Thanks, Jakob. It was really interesting, and I really enjoy talks that make you think more about the concepts. Having a little bit of a break from data. And I have lots of questions, but I guess the one that is more bugging me is when you were explaining that from a thermostat to
a strange thing.
A strange thing, yeah. Say human, we lose that connection between the action and the internal states. And I'm just thinking, why would evolution make us that way? Because you would spend a lot of energy in trying to figure yourself out, I guess. And so doesn't seem to follow an efficiency principle. Yeah. So yeah, I wonder.
Great question. And so the question is, when we go from active things like thermostats to strange things like mammals, let's say, and the hypothesis here is that you lose this connection, that your actions you're not directly informed towards your beliefs of what your actions were. You have to infer it. It seems energy inefficient. It's for the soon contingent. I think that we're creatures of volatility, right? So our niche, our evolutionary niche, is a statistical niche. We've learned to exploit volatility And we've learned to inject volatility or nonlinear changes into the way that things happen in order to kind of get ahead of the pack, essentially. And to do that, we need really deep hierarchies. We need to be able to kind of detach ourselves from the situation and say, oh yeah, no, everyone else is. I did it when I introduced myself. I said, when I'm speaking to scientists, real scientists, I do the philosophical thing, right? Whereas when I'm with the philosophers, I do the scientific thing. And that's a way of doing something non-linear. I'm exploiting the situation. I know that this group had, the causal trajectory of this group is different from the philosophers. And I'm now changing my own behavior in ways I can kind of model my own behavior as a successful agent. And if I was just like a thermostat, I'd skip the same talk, no matter what the audience is. So I'm not sure it is a good example, but I've been thinking a lot about this idea that we are essentially agents of volatility. Like we are the agents we are because we navigate so beautifully in volatile environments, moving into Antarctica and, like getting ahead of other kinds of species, niches and so on, but also that we are engendering volatility in the environment. And I think for that, we need something like this detachment that comes from that move. So for me, it's quite an interesting thing.
I'm still trying to get my head around the relationship between being a thing and a Markov blanket. So in your diagram there, I'm trying to understand what was the. So are you saying that the node is the thing or the blanket is the thing? And if it's the blanket that's the thing, then blankets can clearly overlap with each other. And does it matter that that's the case, or?
Yeah, good question as well. So around this idea that what it is to be a thing is to, I think I said, be a Markov blanket. So the thing is the blanket states and the internal states. So that's the kind of first step of the definition. But you can have nested blankets for sure. And a lot of the interesting work from Lars and Smith and others now is looking at if we call each thing or each blanket a particle, looking at metacognitive particles, where one particle with its own little Markov blanket internally to the brain can look at other kinds of systems. There's some interesting work in evolutionary biology as well around the way that different kinds of genetic and epigenetic blankets kind of connect to each other. So you have these kinds of nested blankets. Then I think you also have overlapping blankets in ways where social groups and individuals and so on probably form some kind of overlapping blankets. And within society, let's say, there are lots of things. So I'm willing to cast a Markov blanket around universities and say universities are a thing because there's a Markov blanket under some description for universities, even though it's not a traditional thing. And of course, there'll be lots of overlapping blankets there. That's not to say there are no difficult questions here at all, but it's an interesting starting point to be very, very liberal about what it is to be a thing. So essentially, if you're not a thing, you don't have a Markov blanket. So all your states are now dispersing freely through state space, right? And anything that is not dispersing freely through state space is a thing, right? So it's extremely generic and liberal.
This is sort of a kind of broad question, but I guess if from the sort of perspective of thinking of consciousness as performing this kind of action, what's your overall explanation for cases in which we seem to be really bad at things that system should be really good at? So like, why do you have, for example, you mentioned like psychopathology examples, like something like body dysmorphia, where you've got very consistently wrong appraisals of something you should have a lot of evidence for, or like really bad predictions of probability, which seems like something you should be really good at if you're doing this, but people are consistently wrong in predictable ways.
Yeah. So that's the question really about the complete class theorem and what is false inference here. So part of the answer that people sometimes use here is this, well, something might go wrong in the brain in terms of the message passing that just makes you, some organic damage of some sort that makes your inferences go wrong. Does that then reflect that your priors have changed, or are your priors the same, but they're not, there's something, I don't know. I also like to, so for me also, it's this idea of variational inference that approximates, so approximate inference, where you get closer and closer to exact inference by varying, different parameters and so on. So you the kind of mental image is that exact inference will very quickly converge on a certain answer. That's the kind of ideal. That's the rational thing to do. But as you approximate that, you can cycle back and forth depending on all sorts of different decisions about exploit or accuracy and complexity and so on. You have certain kinds of beliefs about you measure your complexity according to a certain time scale. So if you have an overly complex model, it'll be bad at predicting things way into the future, but it might work really well in the short term. And what your kind of preferred time scale is for assessing the complexity of a particular explanation of something can be quite idiosyncratic. And that can mean that you can you can occupy quite a lot of time being quite far away in your approximate inference from the exact inference. And that can look, even though it is rational, technically speaking, it can look irrational because you're kind of occupying a bad minimum or something like that. I'm not sure that makes sense.
Okay, we've hit noon, so let's thank Jakob one more time.